we are going to work one more problem using the rules of logarithms in order to combine a logarithm, a sum of logarithms into one single logarithm. The problem that we are working is the problem that you see right here on your screen. What I want to remind you is that when you have a sum of either numbers or variables with numbers, anything like that, to raised to a power k, we cannot distribute the k inside the parentheses. Although we have the following property for exponents, if we have a product of two different variables, or a number and a variable, then we can distribute the x to the k times y to the k. And this is fine. This cannot be done. So you need to remember, do not distribute. This is not allowed. The reason that is not allowed is because these two expressions that you will get are not equal. Okay, we can see together an example why they are not equal, but later. Let's focus now on our expression. So we will start again with the product, with the power rule, and we will use the power rule for each one of the terms. And I have here one term, two terms, and three terms. And I will use the rule of the power rule in order to rewrite those terms as logarithms of powers. So the first one will give me log with argument x to the fourth. So I'm using the power rule the other way, so I move now the 4 to as an exponent to the x. Minus, the constant that I have is 1/3, and this will go to as an exponent inside the argument. So I have x squared plus 1 to the 1/3 plus, and now I have the number 2 that I need to bring as an exponent here, and this will be log of x minus 1 square. Okay, now this is what I meant when I said right here that you need to be careful when you have a sum or a difference actually of variables and numbers raised to an exponent. You cannot distribute the exponent, so don't make this mistake. This stays as is for the moment. So the next step is that the first logarithm is ready, the first term is ready, the second term is ready, the third term is ready. So now we should apply the product rule. Now remember that by applying the product rule, it means that you take all the logarithms that they have a plus sign in front of them and you add them together. So I have log of x to the fourth plus log of x minus 1 square. So this is the two logarithms that I will apply the product rule. And let me write it right here. So I'm working with log of x to the fourth plus log of x minus 1 square, and I ignore the middle term for the moment. I will, because it has a minus sign, and I will work with that in the next step. So I need to combine those two using the product rule. The result for those two will be log of x to the fourth times x minus 1 square. And that will be my answer. You can put it in parentheses if you want, just to make sure that you have everything and you know what is your argument for this logarithm here. So now, instead of using the first term right here and the third term right here, I'm going to revise my expression, and I will combine them into what I found to be their product, and this is log of x to the fourth times x minus 1 square. Keep it in a parenthesis, and now I rewrite the middle term that I haven't used until now, and I have this minus log of x squared plus 1 to the 1/3. As you can see, I haven't touched the exponent right here. I keep it as 1/3. If you want, at the end, you can change it into a radical. Right here now I have two logarithms, right? And I have the difference of two logarithms, so I can apply the quotient rule. So this means that this one will be the numerator and this will be the denominator of the logarithm. So I combine now this into one logarithm. Remember, one logarithm, and everything that I get is going to be the numerator and the denominator of the fraction. So I have x to the fourth here times x minus 1 square divided by x square plus 1 to the 1/3. And I'm done. I have combined the entire logarithm into one logarithm, one single logarithm. Now, if you want, you can change the exponent, the radical exponent, into a root. What type of root? Since the denominator of this exponent is 3, this means that the root that you will use will be of order 3. So you have this x minus 1 squared, the numerator, divided by the third root, and everything will be under the root of x squared plus 1, and this will be your final result. You cannot simplify anything here. You do not need to expand this, although you may know how to expand it, and you cannot do any simplifications under the root. So what you see right here will be your final result.